Very good morning, good afternoon. I'm Prad Thiruvenkatanathan. I'm one of the co-founders and directors of LYTT, a data analytics startup backed by BP, focusing on delivering digital products that fundamentally transform surveillance capabilities in the upstream oil and gas sector. A few words about myself. I worked as a data scientist and subject matter expert for fiber optic sensing within BP prior to founding LYTT. And during my time in BP, I invented, productionalized, and deployed industry-leading surveillance technologies for production optimization within BP's upstream operations. These have consequently added millions of oil barrels worth of production benefits and have now formed the foundations of the products that we offer within LYTT. I'm really excited to be presenting the first webinar of our SpotLYTT series to talk more about what we do in LYTT and how we've managed to add and protect nearly $500 million. Yeah, you heard that right. $500 million worth of value to our customers. I'm joined here today with a few of my super talented teammates, James, Janti, and Henrik, who will talk more on how we learn and apply leading edge technologies within LYTT to crack some of the hardest analytics challenges in the energy industry. James, would you like to introduce yourself?
Yeah, so I'm James Ramsey. I'm a data scientist here at LYTT, and I'm responsible for developing our inflow profiling capabilities. I joined LYTT earlier this year, and before that, I worked for about 5 years as an engineer at an oil and gas consultancy here in London. That's me.
Yep. Right. Thank you, James. Janti?
Hi, everyone. I'm Janti. I've been working in the DAS industry since 2009. I've been mainly working on the DAS sensor building and application development. So I've worked in oil and gas, seismic, infrastructure monitoring, whether it's buildings or power line cables. And my main skills are in real-time signal processing, video processing, and machine learning, in hard limited real-time systems. And at LYTT, I'm doing much of the same, which is dealing with terabytes of data streamed from the wells.
Great. Thanks, Janti. Henrik?
Hi, my name is Henrik, and I've been working on infrastructure and system administration for more than 10 years on different industries. My role at LYTT is focused on building infrastructure and also establish cross-team DevOps capabilities.
All right. Thank you, Henrik. For those of you who have not heard of LYTT, we are a new data analytics startup backed by BP, delivering a suite of digital products that I'm proud to say are fundamentally transforming surveillance capabilities within the upstream oil and gas sector. We started as a 4-person company about a year ago, and we're now about 30 people with plans of scaling rapidly in the coming year. We are looking for some top talent, both in digital and within the oil and gas space. So if you're keen to be part of our lean, mean, scale-up machine, then please do drop us a note or log on to our website to get the latest in the job postings. Let's talk a little bit about what we do. We use fiber optic cables as temperature and acoustic sensors within hydrocarbon wells to listen to different events, like sand entering a well or building up, or gas bubbles in oil. We use our proprietary algorithms to pattern these events and also work out where these events are happening within the wells using streaming analytics. We then present these as real-time operational insights through a scalable cloud-based data platform to inform what actions to take to mitigate safety risks and enhance production efficiency. Think of this almost like Shazam, but for oil and gas wells. We have a number of products on offer. We have the first product there is a real-time downhole sand monitoring capability that identifies and pinpoints zones of sand entry in oil wells within 5 seconds of the event. 2, we've got a well integrity monitoring solution that lets you identify leaks and flow behind casing across the entire length of the well simultaneously and in real time using a single fiber optic cable. Again, a technology unlike anything else in the market. 3, we are also now field trialing the industry's first real-time multi-phase inflow profiling capability, what is regarded as the holy grail in the oil industry that gives relative production allocations in near real time. 4, we are also working on integrating vertical seismic profiling capability to our product suite, where we use the same fiber optic cable as a seismic receiver array to image the near wellbore area, almost like ultrasound imaging, but applied to the subsurface. The question that you may now have is, how do these products actually translate into dollars in the energy industry? Let's do some math. 1 barrel of oil is now averaging around $65. So an addition of 1,000 barrels of oil a day is then worth roughly $65,000 a day. Multiply that by 365, and all of a sudden you're looking at very big numbers. That's roughly $25 million of gross value added. Our downhole sand monitoring product alone has now helped both add and protect several thousand barrels of oil a day through its deployment within BP. As you can see from some of our published case studies that we have on our website, and this has accounted for hundreds of millions of dollars worth of value to our clients. Anyone working within the oil and gas sector would also talk to the paramount importance of safety within the industry. We now have a real-time capability that lets you diagnose leaks and flow behind casing in near real time using a single fiber optic cable. This has now been used effectively to fix wells and also in one instance effectively bring a shut-in well back to life, aiding improved efficiency and safety. Let's now look a bit under the hood of our tech stack. The way we deliver a cutting-edge capability is by constantly developing and, where appropriate, leveraging the latest and the greatest digital technologies that are out there in the market. We process massive volumes of data, and I'm talking tens of terabytes of data an hour. Put that in perspective, that's about 10,000 movies worth of data every single hour, processed in a flash using industry-leading analytics, and we present these processed insights in a user-friendly dashboard within seconds. We do this by running our algorithms within a highly scalable cloud-based tech platform, alongside industry-leading edge compute and machine learning capabilities that I'll now request James, Janti, and Henrique to talk more on. Janti, please can you introduce how we use edge computing within LYTT in our products?
Yeah, so why do we need the edge? When we collect data, data starts life as pulses of light going down the fiber optic well. This light captures the changes in vibration and sound that's occurring down the well. And that's the data that we're using to generate value to the client, essentially finding anomalies, finding that everything's okay in the well. So the data rates on the edge at the well are about 1 terabyte an hour per well, or per fiber optic cable being monitored. So that's essentially like 70 HGTVs that need to be processed simultaneously without any stalls. Otherwise, we won't have a product. So how do we do this? We've been smart about the way we chose technologies. So we rely on high-speed networking, the latest and greatest. We also rely on very fast storage. And we also are using the latest and greatest in the graphics processing units that are in the market. So we're using graphics processing to accelerate the compute that is required to be run on the edge. So if you measure a multi-well stream on the well, you'll end up with 5 or tens of terabytes of data that needs to be processed. On the cloud, it's impossible to transfer such amounts of data for processing. So what we do is we figure out how to identify the signatures of all the applications that we're developing. So essentially, we convert raw acoustic data into features that can be transmitted down the wireline to the cloud and to be able to be processed on the edge. So we use edge compute to convert terabytes of data into megabytes of data, to allow applications to exist and work. And we do that in the space of almost 2U. So the infrastructure is not that big. And there's work in the pipeline to increase it to cover about 40 wells without requiring a data center. So in essence, what we're doing is enabling streaming high-performance computing on the edge to pretend as an IoT device that supplies data to the cloud, and to do the machine learning and inference on the edge or the cloud. And at the same time, we developed it in such a way where, for example, James will be developing a new machine learning model. We don't need to ship new kit to the well site to enable new applications. We just hit update. The application gets updated both on the well and in the cloud. Simple.
All right, thanks, Janti. That was good. So, James, can you please enlighten us on what we mean by hybrid modeling in LYTT and how we use this to deliver real-time operational insights?
Yeah, sure. So one of the things we do here at LYTT is use distributed acoustic and temperature data to estimate things like oil inflow, gas inflow, water flow at each depth in the well. So what sets LYTT apart is that we approach this problem using a combination of both first principles and data-driven modeling. So first principles would be using a physics-based model to estimate what the acoustic signature of, say, gas inflow might sound like, and then comparing this to what we see in real well data. A data-driven approach would be acquiring a set of acoustic data that's correctly labelled as oil inflow, gas inflow, and so on, and then using the empirical model, a machine learning model, to learn to predict each of these events. So you can get a limited amount of success by using one of these models on its own, but the real gain has come from using a hybrid modeling approach that combines the physics and the data-driven modeling approach. Building a model that works on one well is quite simple. Just throwing a machine learning model at the problem would work pretty well. But the real challenge is to build a model that can generalize not just to one well, but across a whole load of wells. And what we really find here is that it's absolutely critical to use the combination of the physics-based model and the data-driven model to allow the model to generalize properly across multiple wells. So LYTT, fortunately, is in the position of having the industry expertise and experience to handle the sort of first principle side of things, but also we've taken the time to acquire vast amounts of labeled data, both in terms of real well data from the operators that we work with, and also from laboratory type tests that we conducted. So this puts us in a pretty unique position to hopefully lead the way in this area of the industry.
Great. Thanks, James. Henrik, we've been talking about extracting features on the edge, converting these into meaningful insights using hybrid modeling methods. Can you please comment on how we can now turn these into products that we can deploy at pace and in near real time?
So data that is processed on the edge is transferred to our cloud infrastructure, and then from there on, we're using an event-driven cloud architecture, which was designed to be both reliable and scalable. So it doesn't really matter how many wells you have; we can handle the data. All the data is processed in real time or near real time, depending on the needs of each customer. And we're using a multi-tenancy cloud architecture where each customer has its own isolated environment and isolated account. So there's no way we can have data from one customer going to a different customer. All the data is also encrypted in both transit and in storage. And we always use private networking, and there's no way you can access that data from the internet.
Okay, that's great. Thanks, James, Janti, and Henrik. And thanks again, folks, for joining us for this episode of SpotLYTT. I hope you enjoyed the webinar. Let's now open it up for questions from the audience. We'll try and take as many as we can in the next 15 minutes or so. All right. Let's see now. Okay, so we've got one from Bernard. What is the difference between LYTT's DAS inflow profiling capability and conventional services such as wireline production logging? Perhaps, James, you can take this one?
Yep, okay, sure. So the key difference between, so when we talk about wireline production logging, that's what people normally refer to as a production logging tool. And the key difference between what a production logging tool or a PLT offers and what LYTT's DAS capabilities offer is that a PLT is essentially just a snapshot in time, whereas DAS offers you the capability to continuously monitor your well. So there are two main advantages to having continuous monitoring. The first of these is that during a well's lifetime, there are certain key events that you'll want to monitor and react to and understand. In an oil well, this might be the first time that the well starts producing water. And for an event like a PLT, the chances of acquiring that data at the same time as one of these events is next to zero. So that's the first sort of obvious advantage of continuous monitoring. Secondly, once you have this continuous monitoring, you're able to start to build up an understanding of the relationship between what's happening downhole in the well and the controls you're applying to the well at surface. So things like the choke setting or the amount of drawdown you're applying to the well. And once you have this understanding, you can start to predict the way that your well is going to behave, and you can start to optimize the way that you control your well. So this might be choosing the correct drawdown to minimize water production, which in turn is going to lead to higher oil production rates and adding value. That's all on that one.
right. Thank you, James. Let's take the next question. We have one from Ira. You're talking about measuring acoustics. How do you calibrate the data from well to well? Perhaps, Janti, you can take this one.
Yeah, I'll take that one. So we do calibration in three phases. First of all, each fire vortex sensor is unique in its own way. So we find a way to make them as close as possible to each other. And then every well and the instrumentation is also different. So we do a second stage calibration per well. And also every different application requires a slight adjustment to the way data needs to be normalized or massaged for the app to work. So an analogy is like in the Shazam world, you can classify between a jazz song and a classical song just based on characteristics. So we make sure that these characteristics per application on the well are translated in such a way that makes the classification work for all of them. So if we essentially sift the wheat from the chaff and we make it work for the signals that we're interested in.
Okay, great. That's good. So I think there's a question from John here as well, John Davies, who talks about, let me read this out. Recognizing that every well and every field is different, how many wells or fields worth of data will we need before you will be able to achieve reliable event classification or randomly selected wells/fields? And how many different fields have you worked with to date? Okay, so I think there's another question from Jack as well, which is along the same lines, which is, sounds a great story. Similar question to John's, how extensively have you deployed the technology? All right, so perhaps I can take this one, guys. So our sand monitoring solution has now been deployed over 150 times in high-rate oil wells using both intervention and permanent fibers. We've also run a well integrity monitoring solution over 30 times across 4 regions around the world. We are now in the process of deploying our inflow monitoring, the multi-phase inflow profiling capability in one asset, and our VSP processing solutions for multiple clients as well. All right, let's now take another one. Okay. What is the limitation of sensors? For instance, can the LYTT sensor be deployed in HPHT, high pressure, high temperature environments? Okay, the answer there is it depends on the kind of deployment you use, Mohammed. So fiber in itself do have very high temperature ratings, and we have seen fibers being deployed in wells with temperatures going up to about 100 degrees or so, but then there are fibers that can operate at much higher temperatures as well. And just to be clear, the fibers don't have any additional electronic gauges attached to them. So the fiber itself is the sensor here. So as long as you have the right coatings and the right cable configuration, I think you could potentially go up to higher temperatures as well. Okay. There is one other question that has now come up. If I would use your service, where is my data stored and is it safe? Henrik, maybe you can take this one.
Yes. So LYTT's cloud infrastructure is leveraging public cloud offerings. And if there is any geographical restriction, for example, if your data needs to be in the US or if it needs to be in Europe, we can accommodate for that. And like I said before, all data is always encrypted and it's always running in an isolated environment with no access from the outside world.
All right, thank you, Henrik. There's another one from Ehsan, which says, can you estimate or quantify inflow profiles in multi-phase flow conditions by your integrated physics and data-driven method? If so, how? Can you please elaborate? I think James did comment on this, but perhaps, James, you can talk a little more about what we do there.
Yep, so with inflow profiling, there are sort of 2 parts. Quantifying the flow rates and then phase detection, so telling the difference between oil and water and gas. So at LYTT, we have capabilities to quantify, for example, liquid inflow rate, and on top of that, we also have phase detection models that rely on it's a hybrid combination of DTS and DAS data. So using these data sources in conjunction, we're able to detect the difference between, say, oil and water. And we're currently deploying that capability in a field at the moment. So it's exciting to see that capability rolled out at the moment. In terms of the exact methods that we use to do that, we can't say too much there. I think Prad
That's the secret sauce.
Brad would cut me off if I did. So I'll leave it there. But yeah, we do have those capabilities.
All right. Thanks, James. So let's look at the next question. Dharmendra, I came to know there is a plan to simulate DAS VSP with other services you have. How do you do that? We are not trying to simulate the service. We are trying to offer the service instead, Dharmendra. So maybe there was a bit of a misunderstanding there. So what we're trying to do there is to have processing capabilities in-house in order for us to use the fiber itself as a seismic receiver array. So we can use it for vertical seismic profiling applications. All right. Next question, can you detect differences in sand size? Potentially, yes. So what we have with the sand monitoring system is an ability to listen to sand particle impingement. So that's obviously going to, if you think about what that means, you're looking at the collisions made by sand with the base pipe. And there's therefore dependence on the kinetic energy, so half mv square. And so there is a mass dependence. And if the velocity is assumed the same, so if the flux is assumed the same, and if you maintain it at a certain rate, then there is a direct dependence on the volumetric concentrations of sand and potentially the size of the sand as well. We've not used the technology specifically to try and detect the differences in the the grain sizes, but we can give some semi-quantitative, I should say. It's not quantitative, it's not qualitative either, it's somewhere in between. It's relative volumes of sand that are influxing. So that's something you can do. We've not tried to use it for detecting the differences in the sand sizes, but as the sand particle size decreases, the ability for you to detect those also drops because the overall mass concentration is lower and the kinetic energy associated with the flow then drops as well. All right. Okay, I think with that, we will draw a close for this. So thanks again for joining us, folks. We have more webinars coming and we look forward to joining you all in the next one. To learn more about what we do or access some of our case studies and white papers, please visit our website at lytt.com. If you would like to learn more about anything specific, please do drop me a line on prad@lytt.com. Thanks again and have a Merry Christmas.